this problem asks us to verify the trigonometric identity. So verify that if we simplify secant squared theta minus 1 over secant squared theta, that it will indeed equal sine squared theta. So because I only have a sine squared theta on this side, I'm not going to touch that side. I'm only going to focus on simplifying this side, the left side. So I'm going to first look at it and think, okay, I've got a secant squared theta here, and I've got a minus 1, I've got a secant squared theta. So first I'm going to figure out, can I simplify the top into one function? It's worth a shot, so let's go look. So if we pull this up, we're going to look at our identities here, and I'm going to look for one that contains secant squared theta. So if I rearrange this one, I have secant squared theta equals 1 plus tangent squared. So if I solve that for tangent, I would get tangent squared theta equals secant squared theta minus 1. Not sure if that's going to help us out too much, so let's just keep that in our back pocket and let's go back and look at this. So we could change that to tangent squared theta over secant squared theta. So actually, I think I'm going to go ahead and do that, because then that'll give me just one function over one function rather than this minus sign up here. So I'm going to do that. I'm going to do tangent squared theta over secant squared theta equals sine squared theta. And you got to bring this sine squared theta down every time, because this is an equation and you're trying to make sure the two sides are equal. So now I'm going to change to sines and cosines, because I've got a sine over here. I don't have any sines here, so I need to change this to be sines. So tangent is, if we go back and look at our equation sheet, tangent is equal to, let's see if I can zoom, oh, there we go. Tangent is equal to sine over cosine. So with that being said, sine over cosine, we can change this to sine squared theta over cosine squared theta equals, now secant is 1 over cosine, so I'm going to say 1 over cosine squared theta, and again, equals sine squared theta, eventually, once we finally simplify this down. So now we think about our fraction rules. We have a fraction divided by a fraction. Remember, if I have a over b divided by c over d, keep, change, flip, I do a over b times d over c. So I keep my first fraction, change division to multiplication, and I flip my second fraction. So now I'll have sine squared theta over cosine squared theta times cosine squared theta over 1 equals sine squared theta. Okay, so now I look and I say, okay, can anything cancel out here? So we can do pre-simplifying. Remember, if I had like 4 over 5 times 15 over 6, we could look at our diagonals and see if we could simplify them. So 5 and 15 can both divide by 5, so that would become a 1, that would become a 3. 4 and 6 can both divide by 2, 4 would become 2, and 6 would become 3. And I would get 6 over 3 or 2 when I multiplied. So pre-simplifying, super handy trick. So sine squared theta and 1, well, that doesn't really help. There's nothing both sine squared theta and 1 can be divided by except 1, which doesn't do anything. But cosine squared theta and cosine squared theta, I can divide both of those by cosine squared theta. So they are going to divide out, and they're both going to become 1. Sine squared theta times 1 is sine squared theta over 1, which would just still be sine squared theta. And sure enough, I get sine squared theta equals sine squared theta. So recap, we figured out that we could combine the secant squared theta minus 1 into one trigonometric function. That helped us then go ahead and get everything into sines and cosines and then simplify from there. And remember our fraction rules: keep, change, flip, dividing a fraction by another fraction, keep your first, change division to multiplication, flip your second fraction. And then we go into the pre-simplifying, which is another skill that we were taught way back when. And you could divide out your cosine squared thetas. So you just get sine squared theta times 1, which is just sine squared theta.